Far in the northeastern corner of Minnesota, the land meets one of the largest lakes on Earth. Lake Superior, the greatest of the Great Lakes, stretches so wide across the horizon that it looks more like an inland sea than a lake. Its waters can turn violent with storms or lie calm and blue under the summer sun, but always there is a sense of immensity, a body of water that holds more than 10% of all the fresh water on the planet's surface. Along its northern edge, where Canada begins and Minnesota ends, lies a rugged shoreline of cliffs, forests, and rivers. This is the North Shore, a place where geology tells a story written in rock more than 1 billion years old. The bedrock of this region was formed during what geologists call the Mid-Continent Rift, an enormous geological event that split North America apart 1.1 billion years ago. Imagine lava, glowing and molten, pouring from cracks in the earth, spreading in sheets across the land, hardening into basalt. Over millions of years, the rift failed to tear the continent fully in two, but the scars remained vast ridges of hardened volcanic stone, valleys, and fault lines that today define the landscape of northern Minnesota. That black volcanic basalt is what the Brule River now cuts across, shaping the land in dramatic ways. The ecosystems that grew upon this ancient stone are equally striking. The forests are thick with birch, spruce, fir, and maple. In spring, the ground is dotted with wildflowers: trillium, lady's slipper orchids, and bluebells. In autumn, the hillsides burst into color, fiery reds, oranges, and yellows that reflect in the waters of rivers and streams. Moose wander in the shadows of the trees. Black bears forage along the edges of trails. Bald eagles ride the winds above the shoreline. And through all of this weave the rivers, hundreds of them, tumbling from inland lakes and marshes down toward Superior. They carve deep gorges, cascade over basalt ledges, and form waterfalls that echo through the valleys. One of these rivers is the Brule River, a narrow but forceful current that runs through what is now Judge C.R. Magney State Park. The Brule has flowed here for thousands of years, its waters fed by rain, snowmelt, and small inland lakes. It cuts a twisting course through the forest, shallow in some stretches and roaring in others, filled with trout and salmon on their way to spawn. To the Ojibwe people, the Anishinaabe, this river, like all rivers, was alive. Water carried spirit, movement, and transformation. To stand by a river was to feel the presence of life, always flowing, always connected. In Ojibwe cosmology, natural features were not mere scenery. They were thresholds, boundaries, and sometimes doors. Waterfalls especially were seen as powerful places. The falling of water marked a transition. The river above was not the same as the river below. Such places were inhabited by spirits, often considered dangerous or trickster-like. To approach a waterfall was to approach a liminal zone, where the seen world and the unseen brushed against each other. While no direct record exists of Ojibwe myths tied specifically to what we now call the Devil's Kettle, the broader cosmology suggests that a hole swallowing half a river would not have been viewed as ordinary. It would have been a place of caution, perhaps reverence, a natural reminder that the earth itself holds mysteries. European settlers arrived in the region centuries later, in the 17th and 18th centuries, drawn first by the fur trade and later by timber and mining. They encountered the Brule River and marveled at its rapids and falls. By the 19th century, explorers and surveyors were mapping the area, often noting the peculiarities of rivers and waterfalls in their journals. Local guides pointed out the strange split in the Brule, where one half of the river fell in plain view and the other half disappeared into a deep, churning hole. The settlers had no stories to explain it, so they gave it a name from their own tradition of labeling the uncanny. The Devil's Kettle. The use of devils to describe natural features is common across North America. In fact, if you scan a map, you'll find Devil's Lakes, Devil's Towers, Devil's Gulches, and Devil's Bathtubs scattered across the continent. Early European settlers often used the Devil's name to mark places that felt dangerous, confusing, or beyond their understanding. A dark chasm in the earth? Devil's Gorge. A rock spire rising unnaturally from the plains? Devil's Tower. A waterfall that swallows water whole? Devil's Kettle. The term reflected both fear and fascination, a way of marking the land as untamed, perhaps even unholy. By the early 20th century, the Devil's Kettle had already become a local curiosity. Newspapers from Duluth and Minneapolis sometimes ran short notes about the strange waterfall up north, where water seemed to vanish forever. Travel guides whispered of a mystery of geology that no one could solve. Visitors who made the long trek up the North Shore often wrote about their experiences in letters and travelogues, marveling at the sight. What they saw was dramatic. The Brule River, after winding through forest and rapids, splits at a cliff. On the left, water crashes down in a standard waterfall, white and foaming, loud and visible. On the right, the water pours into a gaping hole carved into the basalt, the kettle itself. There, the current churns briefly and then slips into darkness. No outlet can be seen. The water simply vanishes. To stand at the railing above it is to watch a river divide. One half revealed, the other concealed. For generations, visitors responded to this mystery with the same instinct. They threw things in. A stick, a branch, a stone. Something buoyant, like a log. Sometimes bottles, marked with names or dates, so they could be recognized if they reappeared downstream. And later, in more organized experiments, entire bags of ping-pong balls, each marked and numbered. None ever emerged. At least, not in any way that could be reliably recorded. No log was spotted bobbing down the Brule after disappearing into the kettle. No bottle washed up on the rocky shores of Lake Superior with its message intact. No ping-pong ball appeared downstream. Visitors would stand by the water, toss something in, and wait. Minutes passed. Hours sometimes. And nothing. It was as if the earth had swallowed the objects completely. This sense of disappearance captured imaginations. It became a kind of local ritual. You didn't just visit the Devil's Kettle, you tested it. You tossed something in and joined the long line of witnesses to its hunger. Even though scientists later warned against this practice, both for the sake of the environment and because of the dangers of leaning too far over the slick rocks, the stories remained. Generations of Minnesotans grew up hearing that, at the Devil's Kettle, things simply vanished. By mid-century, the place was firmly established as a tourist draw. When Judge C.R. Magney State Park was founded in 1957, named for the Minnesota Supreme Court justice who had worked to preserve the state's northern lands, the Devil's Kettle became the centerpiece. Trails were cut through the forest to bring visitors close to the falls. Wooden railings and viewing platforms were built to keep people safe. Interpretive signs explained the basics of the park's geology and wildlife. But when it came to the kettle itself, explanations were scarce. The mystery was too stubborn. Folklore clung tightly to the site. Stories circulated of entire trees swallowed by the kettle during floods, never to be seen again. Some said the water flowed underground for miles before re-emerging, perhaps directly into Lake Superior. Others whispered that the kettle was bottomless, a gateway, not just to hidden rivers but to another world. "The earth has an opening there," one old guide reportedly said, "and it takes what it wants." The bottomless myth is common in folklore. Lakes without visible outlets are often said to be endless in depth, feeding subterranean oceans. The Devil's Kettle, swallowing water with no return, fit naturally into this tradition. Even the name kept the story alive. The Devil's Cauldron, boiling away with secrets. Visitors in the early 20th century wrote about standing at the edge of the falls, feeling both awe and unease. One travel writer described it as, quote, "watching the world fold itself in half, one side revealed, one side hidden." Another recalled tossing a branch into the kettle and waiting an entire afternoon without success. It is gone into the earth, swallowed by basalt. Newspapers leaned into the drama, calling it the waterfall that eats rivers. All of this added layers to the mystery. The Ojibwe had seen rivers as thresholds. Settlers had named it for the devil. Tourists threw in objects that never came back. Each layer of culture added to the sense that this place was not like other waterfalls. And so, as the decades passed, the Devil's Kettle became both a natural wonder and a puzzle. A place of beauty, framed by forest and basalt, and at the same time a riddle that defied explanation. A river divided, half in plain sight, half in hiding. The sound of water rushing into darkness, carrying with it the weight of legend. The Devil's Kettle was never just a pretty waterfall. From the very beginning, it provoked a question that seemed absurd in its simplicity. Where does the water go? Scientists, geologists, and curious visitors all shared the same impulse, the conviction that there must be an answer, and that it should be possible to find it. But decade after decade, the answer remained out of reach. On the surface, the mystery of the kettle seemed like a smaller version of a much larger family of natural puzzles. Disappearing rivers. Around the world, there are streams and rivers that vanish from the surface, only to reappear later, sometimes miles away. These are often found in regions with a special kind of geology known as karst. Karst landscapes form in areas where the bedrock is soluble, most often limestone, but sometimes dolomite or gypsum. Over thousands or millions of years, rainwater, slightly acidic from absorbing carbon dioxide in the atmosphere, slowly dissolves the rock. The result is a landscape riddled with sinkholes, caves, and underground channels. In such regions, rivers can vanish into the ground as if swallowed, flowing invisibly beneath the surface before re-emerging at a distant spring. One of the most famous examples in the United States is the Lost River of Indiana. Flowing through the limestone country of southern Indiana, the Lost River disappears into sinkholes and caves for much of its course. Entire stretches vanish underground, only to burst out again at springs miles away. For centuries, locals told stories about the vanishing waters, and even today the river's pathways are not fully mapped. Explorers crawl through damp caves and flooded tunnels, trying to trace its route. Another striking example comes from Kentucky, home to Mammoth Cave, the largest cave system in the world. There, streams frequently drop into sinkholes, vanishing from sight, only to run through dark caverns deep beneath the earth. In fact, much of Mammoth Cave was carved by these underground rivers. Water dissolves the limestone, widens cracks, and leaves behind a labyrinth that stretches for hundreds of miles. To walk inside Mammoth Cave is to see the very arteries of the earth laid bare. Elsewhere, in Slovenia, the Skokjan caves contain the Reka River, which disappears into a massive underground system. In Mexico's Yucatan Peninsula, entire rivers vanish into cenotes, natural sinkholes formed in limestone. In China, in the karst regions of Guizhou and Guangxi, underground rivers carve valleys and re-emerge in spectacular springs. The theme repeats across the world. Rivers disappear because limestone dissolves, opening paths beneath the surface. Given these examples, it seemed natural at first to imagine that the Devil's Kettle might be another karst phenomenon. The Brule River might be slipping into an underground passage and re-emerging elsewhere. And yet, the geology of northeastern Minnesota told a different story. The bedrock of Judge C.R. Magney State Park is not limestone. It is basalt, a volcanic rock formed during the mid-continent rift over 1 billion years ago. Unlike limestone, basalt does not dissolve easily in water. It is hard, dense, and resistant. Water can erode it over long stretches of time, but it does not produce vast cave systems. In karst country, rivers vanish because the rock beneath them is riddled with voids and tunnels. In basalt country, such voids are rare. This made the Devil's Kettle unique. Here was a waterfall behaving as though it were in limestone country, swallowing half a river whole, but set in a volcanic landscape where such behavior should not exist. Geologists struggled to reconcile what they saw with what they knew. If the kettle was not a classic karst sink, then what was it? One theory suggested that the kettle might be connected to an ancient lava tube. Lava tubes are long, hollow tunnels that form during volcanic eruptions. When lava flows downhill, the surface often cools first, solidifying into a crust. Beneath that crust, molten lava continues to flow. If the eruption ends, and the molten interior drains away, a hollow tube is left behind. Some lava tubes in Hawaii stretch for miles, large enough to walk through. If a lava tube lay beneath the Brule River, perhaps the water was flowing into it, traveling unseen underground. The idea had an elegance to it, a marriage of fire and water. Ancient lava shaping the path of a modern stream. But geologists were skeptical. Lava tubes are common in young volcanic regions like Hawaii or Iceland. In Minnesota, the basalt of the mid-continent rift is ancient, more than 1 billion years old. It formed not as rivers of lava flowing across the land, but as enormous sheets of molten rock pooling and cooling over vast areas. These kinds of eruptions do not usually produce hollow tubes. Over 1 billion years of erosion, weathering, and glaciation, any such tubes that might once have existed would likely have collapsed or filled with sediment long ago. the odds of a lava tube persisting intact, precisely where the Brule River flows, seemed vanishingly small. Still, for many years, the lava tube theory remained one of the few semi-plausible geological explanations. If not a tube, then perhaps a network of fractures or fissures in the basalt, wide enough to channel water. Which led to another theory, that the Devil's Kettle connected directly to Lake Superior. Lake Superior lies just a few miles downstream of the Devil's Kettle. Its waters stretch more than 160 miles across and nearly 350 miles in length, with depths plunging to over 300 feet. It is so vast that it creates its own weather systems, whipping up storms that have sunk hundreds of ships. To stand on its shore is to feel the presence of something oceanic, something almost beyond comprehension. Could the missing waters of the Brule flow directly into this great lake? Some believed so. If cracks or fissures in the basalt beneath the Kettle extended all the way to Lake Superior, then perhaps the river simply drained into it invisibly. This would explain why nothing tossed into the Kettle ever appeared downstream in the Brule. The objects, people reasoned, were carried directly to Superior, where they were lost in its immensity. But here too doubts arose. Hydrologists pointed out that if a fissure large enough to carry half a river did connect to the lake, it should be visible in some way. Objects tossed in logs, bottles, ping-pong balls should eventually wash up on the shore. And yet, not a single confirmed case ever emerged. The Brule's missing half seemed too substantial to simply disappear without a trace into the lake's waters. To move beyond speculation, scientists attempted direct experiments. One method was dye tracing. This technique involves pouring harmless, brightly colored dye into the water and monitoring downstream locations for its appearance. It has been used successfully around the world to map underground rivers and springs. In karst systems, dyes often emerge miles away, revealing the hidden pathways of water. At the Devil's Kettle, however, dye tests consistently failed. No colors ever appeared downstream. This baffled researchers. If the water was rejoining the Brule, the dye should have marked it. If it was flowing to Lake Superior, the dye should have been detectable near the river's mouth. Yet no traces were found. Other experiments used physical markers. Ping-pong balls, lightweight and buoyant, were dumped into the Kettle in large numbers, each marked for identification. Logs and sticks were tossed in. Even small, brightly painted objects. None ever re-emerged. Why did these methods fail? Some suggested the dye may have been too diluted to be visible, mixing invisibly with the torrent of the Brule. Others argued that the turbulence of the Kettle might shred or trap physical objects, preventing their escape. Still others proposed that the water might rejoin the river so quickly and so seamlessly that the dye and objects simply went unnoticed. The lack of results, rather than discouraging curiosity, only deepened the mystery. Each failed attempt seemed to prove that the Devil's Kettle was more than a puzzle of hydrology. It became, in the public imagination, a geological riddle that defied science itself. The Kettle was hardly the first natural puzzle to confound scientists and capture the public imagination. History is filled with such enigmas. In California's Death Valley, the sailing stones mystified observers for decades. Large rocks appeared to move across the desert floor, leaving long tracks behind them, yet no one had ever seen them move. Only in recent years did scientists discover the cause. Thin sheets of ice forming under the stones on cold nights, allowing them to slide when pushed by light winds. The solution was simple, but for years the stones seemed supernatural. In Australia, the Morning Glory Cloud, a massive rolling cloud formation stretching for hundreds of kilometers, baffled meteorologists. Locals flew gliders through it, surfers of the sky, while scientists struggled to explain it. Eventually, it was found to be the result of unique atmospheric conditions. But for many, the cloud's beauty and strangeness were explanation enough. And in physics, black holes served for decades as a kind of cosmic devil's kettle, places where matter and energy seem to vanish beyond comprehension. Even today, while their mathematics is understood, they remain symbols of mystery, thresholds beyond which we cannot see. The Devil's Kettle fit comfortably into this tradition. Like the sailing stones, like black holes, it seemed to devour matter and offer nothing in return. Its very resistance to explanation made it captivating. People love unsolved mysteries, perhaps more than solved ones. Why do we fixate on places where things disappear? Part of it may be fear. To vanish is to step outside the ordinary laws of nature. We are creatures who rely on continuity. Rivers flow, objects fall, causes lead to effects. When continuity breaks, our minds recoil. But another part of it is wonder. The idea of vanishing invites imagination. Where does the water go? Into hidden caves? To a distant lake? To another world entirely? A mystery unravels into infinite possibilities. The Devil's Kettle joined other famous vanishing phenomena in human imagination. The Bermuda Triangle, where ships and planes supposedly disappeared. The Marie Celeste, a ship found abandoned with its crew gone. Even legends of people who walked into forests or mist and were never seen again. Each of these, in their own way, plays upon the same chord. Disappearance as the ultimate unsolved riddle. And so the Devil's Kettle remained, for decades, not only a hydrological puzzle, but a cultural one. It was a reminder that even in a world mapped by satellites and explained by science, there were still places where nature whispered, "Not yet. Not here. Not so easily." For decades, the Devil's Kettle resisted every attempt at explanation. Objects thrown in never reappeared. Dye tracers dissolved into nothing. Theories piled up, but none could be proven. It became the kind of puzzle that seemed destined to remain unsolved, like a magician's trick performed by the Earth itself. But in 2017, the curtain was finally pulled back. The answer did not come from a dramatic expedition into underground caves, or a sudden breakthrough with new technology. It came from a quieter, humbler approach. Measuring. Sometimes the most stubborn mysteries yield not to flashy experiments, but to patience and arithmetic. Hydrologists from the Minnesota Department of Natural Resources decided to tackle the problem directly. Instead of guessing where the water might go, instead of dropping dye or objects into the kettle and hoping they would show up somewhere else, they turned to the fundamentals of river science. The plan was simple. Measure the volume of water flowing into the Devil's Kettle, then measure the volume flowing downstream. If there truly was water vanishing into the earth, the numbers would reveal the loss. To do this, they used a standard technique in hydrology: discharge measurement. Discharge is the total volume of water moving through a river channel per unit of time. It is usually measured in cubic feet per second or cubic meters per second. To calculate discharge, you need two things: the cross-sectional area of the river and the velocity of the water flowing through it. The cross-sectional area is measured by mapping the depth and width of the river at a given point. Hydrologists wade into the stream with measuring rods or use sonar instruments to trace the shape of the channel. Velocity is measured using devices called flowmeters, instruments with small spinning propellers or electromagnetic sensors that record how fast the water is moving. By multiplying the area of the channel by the average velocity of the current, scientists can calculate exactly how much water passes that point each second. It is not glamorous work. It requires patience, repetition, and attention to detail. Hydrologists often stand in cold, rushing water, carefully recording measurements at multiple depths across the channel. But the results are precise. Discharge studies are the backbone of hydrology, used everywhere from flood forecasting to water management. They are the kind of quiet, rigorous measurements that rarely make headlines until they solve a mystery. At the Brule River, the team measured the flow above the falls, just before the split. Then they measured again downstream, after the Devil's Kettle, where the Brule continues on its way to Lake Superior. If the Kettle truly swallowed half the river and sent it elsewhere, the downstream flow should have been significantly reduced. But it wasn't. The numbers matched almost perfectly. The volume of water flowing into the Kettle was the same as the volume of water flowing downstream. Within the margin of error, there was no missing water. The Brule was whole. The conclusion was unavoidable. The water that poured into the Devil's Kettle did not vanish. It plunged into the pothole, rushed through unseen cracks in the basalt, and rejoined the main river almost immediately, underground and out of sight. The illusion of disappearance was just that, an illusion. The findings were announced in early 2017. Local newspapers ran headlines like "Mystery of Devil's Kettle Solved" and "Scientists Finally Explain Vanishing Waterfall." Reporters quoted hydrologists who explained the results in calm, methodical terms. "The water goes back into the river," one researcher said simply. "It has to. The measurements show it." For many, the reaction was relief. At last, the puzzle was resolved. A question that had nagged for generations was finally answered. But for others, the reaction was disappointment. Visitors interviewed at the park that summer confessed that they had hoped for something grander. "I wanted it to be a tunnel to Lake Superior," one tourist said. Another admitted, "I like the mystery better. The science is kind of boring." Even some locals expressed reluctance to let go of the legend. A woman who had grown up hearing stories of logs swallowed forever by the Kettle said, "It feels like losing a ghost story." This tension between science and story, between truth and wonder, is not unique to the Devil's Kettle. Many natural mysteries have ended the same way. Not with fireworks, but with quiet explanations. Take the sailing stones of Death Valley. For decades, people walked across the racetrack playa and marveled at the large rocks that seemed to move on their own. Heavy boulders, some weighing hundreds of pounds, had slid across the dry lake bed, leaving long tracks behind them. Yet no one had ever witnessed the movement. Theories abounded. Some thought wind pushed them, though it seemed impossible for wind alone to move such heavy stones. Others speculated about magnetic forces, or even pranksters. The mystery endured for nearly a century. Then, in 2014, a group of scientists set up time-lapse cameras and GPS trackers on the rocks. They discovered that on cold winter nights, thin sheets of ice formed under the stones. As the sun rose, the ice broke into panels that floated in a thin layer of water. A light breeze pushed the ice, and the ice carried the rocks with it slowly but surely across the playa. The mystery was solved. The explanation was simple, even mundane. Wind, water, ice. And yet, for those who had cherished the mystery, the solution felt anticlimactic. The romance of moving rocks gave way to the mechanics of frozen puddles. The magic was gone, some said. But others pointed out that the truth was no less beautiful. The desert, wind, and ice working together to produce a phenomenon rare and fleeting, a collaboration of forces that required just the right conditions. The Devil's Kettle was the same. The truth was quiet, almost disappointingly so. No vast lava tube, no hidden cavern, no tunnel to the depths of Superior. Just cracks in basalt, hidden from view, carrying the water back to the Brule with such efficiency that the eye could not trace it. And yet, this explanation holds its own kind of wonder. Think of the precision required. The water enters a pothole, churns, and disappears. For generations, observers believed it was gone. But beneath the surface, the basalt, ancient rock formed 1 billion years ago, contains fractures aligned just so, channels carved by time, that return the flow invisibly to the river. The Brule reclaims itself seamlessly. The illusion of disappearance is maintained, only because the earth has hidden its plumbing so well. Science is often accused of killing mystery, of reducing the magical to the mechanical. But in truth, science reveals the beauty of the mechanical. It shows us that the ordinary processes of the earth, erosion, gravity, the physics of flow, are capable of producing illusions powerful enough to fool us for generations. The anticlimax is not the end of wonder, but a new beginning. Consider also the case of St. Elmo's fire, the eerie blue glow sometimes seen flickering on ship masts or church steeples during storms. For centuries, sailors regarded it as a supernatural omen, a sign from the heavens. In time, scientists explained it as a natural electrical phenomenon, a plasma created by strong electric fields during thunderstorms. The glow was not a message from the gods, but the whisper of physics. Did the explanation make it less wondrous? Not at all. To see St. Elmo's fire is still to witness the atmosphere alive with electricity, the air itself aflame. The Devil's Kettle belongs to this tradition. Its solution may be anticlimactic in the sense that it strips away the grander legends. But it is profound in another sense. It shows us how nature tricks us, how our senses are limited, how we build myths in the absence of data. And then, When the data arrives, we are reminded that the truth was flowing all along. For the scientists who solved it, the work was not about drama. It was about precision, about closing the gap between perception and reality. Their instruments, standing in the cold river, spinning their tiny propellers in the current, recorded the truth drop by drop. They measured, calculated, and proved that nothing vanished. Half a river cannot disappear. It only hides. For visitors who had grown up with the legend, the answer may feel like a letdown. But perhaps it should not. The Kettle remains what it has always been. A place of power, where water plunges into shadow and the imagination rushes to follow. The knowledge that the water rejoins the Brule does not erase the feeling of standing above it. The roar is still there, the spray on the air, the unsettling sight of a river dividing itself, half visible, half invisible. The anticlimax of science is often like this. It does not arrive with thunder, but with a quiet notebook and a careful hand. It reveals that the world is not a stage for myth, but something stranger. A place where reality itself is enough. To understand the Devil's Kettle is not to diminish it. It is to realize that the earth, in its indifference, can still astonish us. The story of the Kettle's solution reminds us that mystery and science are not enemies. Mystery is the spark, the question that compels us to look closer. Science is the path, the slow, careful tracing of truth. And in the end, when the truth is revealed, the mystery does not die. It transforms. The hole in the rock still swallows water. The mind still wonders. But now the wonder has two faces, the imagined and the real. In 2017, when the Minnesota Department of Natural Resources announced their findings, some headlines used the word finally solved, finally explained, as if the Kettle had been conquered. But perhaps that is the wrong framing. The Devil's Kettle was never conquered. It remains as it was, a pothole in basalt swallowing half a river. What changed was us. We now know that the water rejoins, unseen, unheralded, re-emerging as if it had never left. The Earth's trick has been revealed, but its beauty remains intact. To stand at the railing today is still to feel the pull of the unknown. Your eyes watch the water vanish, and your mind, stubborn as ever, whispers, but where does it go? You remind yourself of flow measurements and hydrology, of cubic feet per second. You remind yourself that it rejoins downstream. But part of you, perhaps the part that loves stories, still feels the thrill of the vanishing. That is the quiet gift of anticlimax. It reminds us that the truth may not be dramatic, but it is still enough. That the world does not need embellishment to be wondrous. That sometimes the greatest mysteries end not in revelation, but in reassurance. The water was never gone. It was always there, flowing beside us, hidden only by the limits of our sight. And in that reassurance, there is a different kind of beauty. Not the beauty of legends or portals, but the beauty of rivers that obey gravity, of rock that shapes their course, of scientists who stand in the cold with instruments and notebooks to remind us that the earth is knowable, even when it feels unknowable. The Devil's Kettle was solved not with drama, but with patience, And in that patience lies its lesson. The world is full of kettles, puzzles that seem bottomless, questions that seem unanswerable. Some will dissolve with time and measurement. Others will endure. But all of them remind us that to wonder is human, and to seek answers is just as human. And so the water still vanishes, still swirls into the pothole, still churns into shadow. But now, when you listen closely, you can imagine its hidden journey, tumbling through cracks, rushing through basalt, and rejoining the Brule just beyond your sight. Mystery remains, not because the water is gone, but because it flows where we cannot follow. And that is enough. Mysteries hold a special place in the human mind. They capture our attention in ways that ordinary explanations often cannot. A river that flows into a hole and vanishes. The very idea presses against our expectations of how the world should work. Water is not supposed to disappear. It is supposed to follow a visible path, to fall where we can see it fall. When something breaks that pattern, the imagination stirs. Psychologists have long studied why the unknown has such power over us. One reason is that mysteries create what researchers call a knowledge gap. When we encounter something we do not understand, our minds crave closure. The discomfort of not knowing pulls at us, like an itch that demands to be scratched. This is why people gather around unsolved riddles, puzzles, and secrets. They are not content until the gap is closed. And yet, paradoxically, even when an explanation arrives, it can feel less satisfying than the mystery itself. The anticlimax of the Devil's Kettle, the revelation that the water simply rejoins the river downstream, illustrates this perfectly. The truth resolved the knowledge gap, but it stripped away the infinite possibilities that had lived in the unknown. When the imagination is free, it can wander anywhere. To caves, to tunnels, even to other worlds. When the truth arrives, the possibilities collapse into one. The gap closes, but so too does the dream. This tension explains why humans often prefer the unknown. We treasure the space for speculation, for storytelling. It is why myths endure even after science speaks. At the Devil's Kettle, the explanation exists. We know the water flows back into the Brule. And yet, when you stand there and watch the river split, your mind may still whisper old stories. Perhaps it really does run to Lake Superior. Perhaps there really is a cavern deep beneath the basalt. The science is accepted, but the myth still lives alongside it. Folklore has a resilience that facts cannot always match. Across cultures, places of natural strangeness are wrapped in myth, even after science has pulled away the curtain. Caves become homes of spirits. Volcanoes are thrones of gods. Storms are tempests of divine anger. These stories add layers of meaning to the landscape. They root places in memory, in culture, in imagination. The Devil's Kettle is no exception. Its name itself is a folkloric stamp. Long before hydrologists with flow meters stepped into the river, people had labeled it with the mark of the uncanny. The Devil's Kettle, a cauldron, a boiling pot, a place of danger and secrecy. Even if visitors today know the science, they will still call it by that name. The story remains embedded in language, and through language it continues to shape perception. In this way, myth and science do not cancel each other out. They coexist, Science tells us where the water goes. Myth tells us why the place matters. Together they enrich our experience. A traveler who reads about the hydrology of the Brule may nod at the cleverness of basalt fissures. A traveler who hears the legend of the bottomless hole may shiver with delight. Both responses are real. Both are part of the human encounter with mystery. The Devil's Kettle also speaks to a broader truth: that nature often deceives us. Our senses, tuned for survival, are not perfect instruments of reality. They are quick, adaptive, but limited. They see patterns where none exist and miss connections that are hidden from view. A half river vanishing into rock looks like disappearance. Only careful measurement reveals the continuity. Nature is full of such illusions. We see the sun move across the sky, when in fact, it is the earth that spins. We see a mirage on a hot road and imagine water, when in reality it is light bent by layers of heated air. We see a rainbow as a solid arc in the distance, when in truth it is a circle of refracted light, endlessly shifting with our perspective. The Devil's Kettle joins this long list of tricks. Our eyes tell us the water is gone, but the world is not built to match our eyes. It is built to follow its own rules, whether we understand them or not. There is a humility in that realization. We are reminded that perception is not truth, that the world is larger, stranger, and more complex than our senses can easily grasp, and that sometimes the only way to see clearly is through the careful work of science. But beyond geology and hydrology, the Devil's Kettle can also be read as a symbol, a metaphor for the hidden currents in our own lives. How often do we feel that something has vanished, lost to us forever, when in reality it has only gone underground, flowing invisibly before resurfacing again? Relationships, ambitions, memories, they sometimes slip from view, disappearing into darkness, and we mourn them as gone. But like the Brule River, they may be flowing still, hidden in the rock, waiting to rejoin us downstream. The kettle reminds us that disappearance does not always mean absence. The unseen may still exist, moving, shaping, waiting. It is a metaphor for resilience, for the way life continues even when we cannot trace its path. What seems to vanish may only be flowing where we cannot see. Philosophers have long reflected on the tension between the seen and unseen, the known and unknown. The Devil's Kettle offers a natural stage for that reflection. Here, the visible world is split in two. One half in light, one half in shadow. One half obeying our expectations, one half defying them. It mirrors the way we experience existence itself. We know part of the world. The rest is hidden. We see some truths. The rest eludes us. Like the water slipping into basalt, reality flows through cracks beyond our vision. In that sense, the kettle becomes more than geology. It becomes a reminder of humility. A reminder that not all questions yield immediately to our gaze, and that even when answers arrive, they may not erase the feeling of mystery. That the unknown is not an enemy to be conquered, but a companion that shapes our imagination. As the day closes in Judge C.R. Magney State Park, the forest begins to quiet. The wind softens. The last light filters through the birches and maples. But the river keeps rushing, as it always has. half falling in a white curtain of spray, half slipping into shadow. The sound of it fills the valley, a roar both steady and endless. You can stand by the railing and feel the spray on your face, hear the thunder of water against rock. You can watch the river divide, see one half crash in plain view, and the other vanish into the earth. You can know, in your rational mind, that the water rejoins just downstream, that the flow is continuous, that the mystery is solved. And still, you can feel the tug of the unknown. Still, you can imagine hidden caverns and secret tunnels. Still, you can sense that the world holds more than your eyes can follow. That is the enduring gift of the Devil's Kettle. Not that it hides water, but that it reveals us, our hunger for stories, our attraction to mystery, our capacity to hold science and myth in the same hand. It is both an answered question and an eternal riddle. Both a solved puzzle and a living legend. And so, even after hydrology has spoken, the kettle endures as more than rock and river. It endures as a symbol of the unseen, of the currents that shape us quietly, invisibly, beneath the surface of life. It whispers that not all that vanishes is gone. But beneath the basalt, beneath the limits of our sight, the flow continues. The forest gathers around it, silent witness to centuries of questions. The river keeps moving, undeterred by names or theories. And the hole in the rock keeps swallowing water, churning it into shadow before returning it to the light. To watch it is to remember that we live in a world of thresholds, where the seen and unseen flow together. And to leave it is to carry that memory with you, that even when the mystery is solved, the sense of wonder need never vanish. The forest grows quiet as evening settles along the north shore. Shadows stretch between the trees, and the air cools with the dampness of water and stone. Along the trail, the sound of the Brule River is constant, a low, steady presence guiding you through the woods. It is a sound older than memory, older than language. The sound of a river moving endlessly toward a greater body, carrying with it the stories of stone and rain. At the overlook above the falls, you pause. Before you, the Brule divides. One half flings itself boldly into the open, white spray rising as it strikes the rocks below. The other half slides into the kettle, into that dark hollow carved in basalt, and vanishes from sight. You know now where it goes, how the flow rejoins the river downstream. You have traced its hidden journey in your mind. And yet, standing here, the feeling is unchanged. The mystery is still present, still alive in the senses. It is in the roar that drowns out your thoughts, in the cool mist that clings to your skin, in the sight of water disappearing where no outlet is seen. It is in the knowledge that what we see is never the whole of what exists. The river carries more than water. It carries imagination. You linger a little longer, watching, listening, letting the sound fill the silence around you. The Devil's Kettle is no longer an unsolved puzzle, but it remains what it has always been, a threshold between the known and the unknown, the visible and the hidden. A reminder that even in explanations, wonder remains. As you turn from the falls, the river continues its endless work. It plunges, vanishes, rejoins, and flows on toward the vastness of Lake Superior. The forest gathers close around it, guarding its mystery, whispering through the branches. And you walk away with the sound still in your ears, carrying it with you like a current, a gentle companion into the night. And now, let the sound of water fade into the background and allow the calm to take you. The mystery remains where it has always been, flowing quietly in the dark, while you drift onward into rest.